Evet, selamlar herkese. Ses deneme. Ses deneme, ses deneme, ses deneme. Ee, evet, ekran paylaşımı yaptım. Tamam. Ee, all right, we start. Hi, everyone. Welcome again. I'm really happy to see you here this week again. Before we start the technical details about how AI works, I think it's better we first look at how AI is already affecting our lives, because the truth is AI is not something far away for or futuristic anymore. It's already around us, shaping the way we live, work, and even make decisions. That's why in the first week of this course, before we start models, algorithms, or structures, we will start by exploring different areas where AI is being used. This way you will have a clear picture of its impact. And then when we study the technical side later, you will understand why it matters so much. Uh, Let's think about the last time you watched Netflix or YouTube and got a recommendation that was exactly right for you. That's AI. Or when your phone automatically unlocks your video pace, that's AI too. Maybe you've spoken to Siri or Google Assistant to set an alarm or find the fastest way home. Again, that's AI working quietly in the background. Now, for today's class, we are going to focus on two very big areas, healthcare and engineering. And one of the main reasons we choose these two is because they are the largest faculties in our university, Istanbul University Cerrahpaşa. Many of you will either study here, collaborate with these fields, or at least benefit from them in your professional life. But beyond that, these two fields are also crucial for society as a whole. Healthcare is about our well-being, our lives, and the lives of people we care about. And also engineering is about building the world we live in, from bridges to buildings to machines, cars, and even the devices we are using right now in this online class. First, let's start with artificial intelligence in healthcare. Imagine a doctor who has to look at hundreds of X-rays even in a single day. Human eyes get tired, concentration drops, but AI never gets tired. It can look at thousands of medical images and detect signs of disease earlier than many doctors. For example, AI can catch a tumor in its earliest stage when treatment is easier and survival chances are higher. AI is also changing the way the medicine is given, what we call personalized treatment. Instead of giving the same drug to everyone, AI can analyze your personal data, even your genetic information, and suggest what works best for you. On the top of that, we now see robots assisting in surgeries, smart systems helping with the hospital administration, and wearable devices like smartwatches that use AI to monitor your heartbeat and warn you before something goes wrong. But of course, this brings up important questions too. Can we fully trust AI in healthcare. Who is responsible if a system makes a mistake? How to make sure the technology is fair and unbiased? These are not easy questions, and they show that AI in healthcare is not just about saving lives, but also making ethical and responsible choices. Now we look at the engineering. I changed the page. Artificial intelligence in engineering. Now let's look at engineering. Engineering is everywhere. Our houses, the roads we walk on, the vehicles we travel in, the energy systems that power our cities. With AI, engineers have tools that allow them to create smarter, safer, and more efficient systems than ever before. For example, instead of testing thousands of prototypes by hand, AI can generate designs and run simulations in hours, saving time and resources. In manufacturing, AI systems check products on the assembly line and spot tiny defects instantly. Also, in aerospace, engineers use digital twins, virtual models of engines or machines that can predict when something will fail before it actually happens. And also in construction, 3D printing with AI is already being used to build houses in just a few days. And these examples matter because the world faces huge challenges today: climate change, energy shortages, sustainable infrastructure, and even the need for new technology and space exploration. AI is also helping engineers come up with solutions to problems that once seemed impossible. So, in this class, as we explore healthcare and engineering, I don't want you just think of AI as a computer program. I want you to see it's a powerful force that is already transforming industries and societies. Healthcare shows us how AI can save lives, change medicine. Engineering shows us how AI can help us build smarter, safer, and more sustainable systems for the future. And remember, the reason we are focusing on these two areas first is because they are not only important for the world, also deeply connected to our university's strengths. By the end of today's lecture, I hope you will all see AI not only as a set of technical tools, but as something that will play a role in your future. Whether you become an engineer, healthcare professional, or researcher, or simply an informed citizen. And the contents in healthcare is, when we count them, first one comes with AI in medical diagnosis and diagnostic systems. And later, it comes personalized. Second topic is personalized treatment and drug discovery. And after that, robotics and automation in healthcare comes. And later that, AI in early disease detection, AI help in or AI usage in early disease detection. Uh, let's start with brief information about this topic. AI intelligence is not just a tool for diagnosis, it is transforming the entire healthcare ecosystem from clinical decision support. It's really important, and to hospital workflow automation and drug discovery and digital health platforms, because in the last years, digital health platforms is progressively important because telemedicine and also remote monitoring economy is getting bigger every day because it's faster, cheaper, and becomes important in healthcare system for these reasons. AI is influencing every corner of medicine. In the past 5 and 7 years, advances in deep learning, large language models, LLMs, and multimodal AI. Multimodal, I mean, you get information from text and image and signal and combine all the features. And later that AI learns something from these features. And also generative AI and federated learning. Federated learning means something about federation, and the inputs comes from different sources, and when you combine all these sources information, the AI gives you more meaningful outputs, and this is important for AI. Below, we expand on each subtopic with real-world examples, recent developments, and practical consideration. Now, AI in medical diagnosis. AI helps in the detection, classification, and measurement of abnormalities in medical images. I mean, X-rays, CT, MRI, ultrasound, PET scans, digital pathology slides, dermatology photos, or etc., or something like this. It also assists in triaging urgent cases, standardizing reports, and analyzing lab and clinical notes. When we talk about some examples in action about this topic, this first one comes with stroke triage. Stroke triage is something really matters in medicine because it's really important to move fast when you see stroke triage, and AI absolutely detects large vessel occlusion on CT scans and sends an immediate alert to the stroke team, and cutting down treatment times radically. And after that, lung cancer screening comes. Algorithms flag small pulmonary nodules and track their growth over time with the time slices, standard time slices, and analyzing the growth size. And when you become more healthier, it absolutely tells you the treatment is going well, and the success of treatment comes with this analysis. And after that, third one is breast cancer detection. AI also in mammography acts as a second reader to catch missed lesions, because you can miss some lesions in CT or MR images. It's really small contours in these MRs, and it's really hard for human being to spot these lesions. And after that, cardiology comes. AI also interprets ECGs, some type of signals for arrhythmia, and estimates ejection fraction from echocardiograms. And after that, dermatology, we said, skin cancer screening apps analyze these small images for malignancy risk, malignment risk. And after that, pathology comes, whole slide analysis to detect micrometastasis and grade tumors more consistently. And when we look deeper into recent developments, we can firstly say LLM-powered radiology assistant is important, automatically drafts structured reports, suggest some ICD codes, and fill missing details. And also multimodal AI, these systems combine imaging, laboratory results, and clinical notes to give you richer diagnostic reports. And we pass to next page. It's about the next topic is personalized treatment and drug discovery. AI integrates genomics, medical history, and lifestyle data to recommend you personalized treatment plans. In oncology, it predicts which therapy or immunotherapy will work best for specific tumor profiles. And let's look at drug discovery, generative AI for molecules. As you know, molecules is small size of some information packages and produces novel chemical compounds. AI produces these compounds and predicts some ADMET properties. ADMET, I mean absorption, distribution, metabolism, elimination, and toxicity. And this prediction is really important. Also, protein folding and interactions comes. Tools like AlphaFold predict protein structures and binding sites, accelerating target identification. And later, drug repurposing is mining existing molecules for new therapeutic uses. This is really important. And also, lastly, clinical trial optimization. AI identifies eligible patient cohorts, predicts side effects, and simulates outcomes. When we talk about examples in oncology, some examples I can give you: predicting treatment response from tumor genomics and PET radiomics. Also, we can count on analyzing rare disease, this prioritizing gene variants for faster diagnosis. And also, I may look into recent developments. First, the LLM plus real-world evidence. We say mining HARs and clinical notes to uncover hidden drug effects. Also, digital twins. We say patient-specific virtual models that simulate disease progression and test therapies in silico. And also, synthetic data generation is important because it enables model training without exposing prior patient data. The next topic is robotics. The robotics and automation in healthcare. As I mentioned, robots like the Da Vinci system allow you minimally invasive surgery with higher precision, tremor reduction, and better ergonomics. Orthopedic and neurosurgical robots help plan and execute bone cuts or implement placements with millimeter accuracy. And also, when we talk about robotics and automation, first comes hospital automation. In pharmacy and logistic robots, automated drug dispensing, chemotherapy preparation, and lab sample transport. We utilize these automation robots or disinfection robots, UV-based autonomous cleaning systems to reduce infection spread in hospitals. or we mentioned to delivery robots, transport food, document and supplies, freeing staff of patient care. This is really important. And when we talk about workflow automation with AI plus RPA, the ambient documentation, the LLMs convert doctor-patient conversation into structured clinical notes during this treatment, or billing and coding automation. I mean, and AI generates codes, appeals letters, and manages denials. Also, triage chatbots. There are some projects about triage chatbots. These chatbots assess patient symptoms and direct them to the right specialty. Let me give some examples about this. There are some logistic robots reducing nurse workload by automating supply transport, because they need to keep going this supply of this transportation, and really the workload on nurse is getting easier and less when we utilize these robots. And the next topic is AI in early disease detection. We can call it early warning systems, EWS. AI monitors vitals, labs, and medications to predict sepsis, sudden cardiac arrest, or ICU deterioration hours before onset. And also in public and health screening, when we talk about diabetic screening, AI at primary care clinics to detect eye disease early for diabetic screening. Also cancer screening, personalized mammogram or CT intervals based on risk. Cancer screening is another utility. And the last one, outbreak prediction. It means analyzing social and logistic data for early epidemic detection. In the early stages, when we spot this detection, epidemic detection, we can have a chance to stop it, it's spreading all around the world, becomes pandemic. But when you do something at the early stage for early epidemic stage, it's really hard for this situation spreading all around the world. And when we talk about wearables and remote monitoring, smartwatches detect some apnea or fall risk. AI analyzes core sounds for respiratory diseases, or monitors heart failure patients for early warning signs. And when we talk about recent advances, these dynamic risk models, they are personalized, they are continuously updated health risk scores, monitoring the patients, and then gives reasonable treatment styles to the doctors. And then federated learning, hospitals can also train shared AI models without exchanging raw data. Also explainability tools. This means heat maps, feature attribution to explain why a model made a prediction. And also implementation tip when we talk about careful threshold tuning, pilot deployments, and patient engagement. Also, I can give you some example case study. Regional hospital implemented an AI stroke triage system, and when a CT scan showed a large vessel occlusion, that means something not good for a patient. The AI immediately notified the stroke team and bypassed ER delays, so cutting door to needle time by 22 minutes. In another department, ambient scribing reduced daily documentation from 45 minutes to 12 per physician, allowing doctors to spend more time with patients. The result, faster treatments, happier staff because of less workload, and improved patient outcomes. We try to give you the examples in healthcare. Now we can pass on engineering. If you have some other questions about AI usage in healthcare systems, you can ask me or email me, because there are many departments in our university about healthcare. I wanted to start from healthcare because healthcare is the top department in our university. And after that it comes engineering department, engineering faculty. And after that I will try to handle with all other faculties and departments to give you examples how you can use AI in your projects or in your homeworks, or after that when you graduate from university you can also use it in your professional careers. So in the first few weeks we will talk about the usage of AI in your departments or in your professional area. And when we understand the importance of AI, we can turn into our focus to technical terms of AI, and also we can look deeper into models used in AI. But in the first week, as I mentioned before, I will try to give you the importance of AI, because you are supposed to realize that AI usage in your professional, it gives you actually maybe promotion, maybe better knowledge, and you can be successful when you use these AI tricks in your profession. Okay, now we'll pass into the engineering side. And when we look at the contents, we see AI in design and manufacturing, AI supported simulation and modeling, autonomous systems, and robotics applications. Also, there are, as you see, robotics is really important in AI. You can use all these robotics projects in healthcare, engineering, or also in other areas, because AI triggers the robotics growth in all over the world. And last topic is AI for problem solving in engineering. Now, let's talk about AI in engineering. Artificial intelligence has become a critical enabler in engineering, changing the way products are designed, manufactured, tested, and operated. In recent years, with advances in deep learning, reinforcement learning, generative design, twins, we use this digital twins term also in healthcare, and predictive analytics. AI has entered fields ranging from civil and mechanical engineering to aerospace, electrical, and industrial engineering. It not only increases efficiency, but also unlocks design solutions that humans might not even imagine. Below, we dive into four key domains, as I mentioned just 2 minutes before. First, let's start with AI in design and manufacturing. Traditionally, engineering design has relied on CAD software and human intuition. Today, AI-powered design tools, especially generative design, explore thousands of design variations simultaneously, optimizing for weight, cost, strength, and sustainability. In manufacturing, AI monitors production lines in real time, detecting defects and optimizing processes. Let's talk about some examples in aerospace. Airbus uses generative AI to design lightweight cabin partitions with complex lattice structures, impossible to convince manually, but 50% lighter. And also in automotive, Tesla and BMW use AI in quality control to detect micro defects in welding or paint finishes. Also, additive manufacturing, it's about 3D printing. AI predicts material warping, print failure risks, and adjusts parameters before fabrication. And last one, electronics, PCB layout optimization using AI to reduce heat and electromagnetic interference. I will look at different recent developments. We see generative design plus AI simulators comes first. It is cloud-based tools like Autodesk or Siemens NX. These tools produce multiple optimized prototypes at once. Also, we can say AI plus computer vision in factories. This real-time defect detection with higher than human accuracy. Also, sustainable manufacturing, AI minimizing material waste and carbon footprint. It's really important in the industry because carbon footprint targets that will be in European Union, and when you produce something, you must leave minimum carbon footprint. If you don't do this, you will be punished, or you cannot get promotions or positive things from your projects, because this will be obligation after 2030. 5 years later, there are many European Union targets on this field, carbon footprint. And also sustainable manufacturing, AI minimizing material waste. I mentioned it, carbon footprint, I forgot, sorry. And next topic, AI supported simulation and modeling. Engineering solutions, simulations, I'm sorry, CFD, this is computational fluid dynamics, or FEA, finite element analysis, and thermal modeling are computationally expensive. These are engineering processes that are really expensive, and AI, especially surrogate models, can approximate simulation outputs much faster. Examples in automotive sector, AI accelerates crash test simulations and predicting structural deformation without needing thousands of physical tests. In aerospace, NASA uses ML models to simulate rocket engine performance under different conditions. Civil engineering, AI predicts earthquake impact on structures faster than classical solvers. And also in energy systems, simulating wind turbine aerodynamics or predicting energy output under different weather scenarios. These are all good examples. And recent developments, when we talk about physics-informed neural networks, it combines physical laws with ML, machine learning, for accurate task simulation. And when we talk about digital twins, we say AI-powered replicas of bridges, turbines, aircraft engines, or manufacturing plants allow real-time monitoring and prediction. And also hybrid and high PCI, high performance computing, it reduced simulation run times from days to hours. Faster iteration, reduced costs, and real-time monitoring. These are important advantages of AI. And next topic is autonomous systems and robotics applications. Engineering has always aimed at automation. With AI, robots and autonomous systems are moving beyond pre-programmed tasks into adaptive decision-making machines. For example, the industrial robotics, robots in smart factories adapt to variations in parts without manual reprogramming, because robots can learn and can handle the problems when you use AI in your system, industrial system. Construction, autonomous bulldozers, and 3D printing robots building structures on site. In aerospace, NASA's Mars rovers, Mars robots, use AI for autonomous navigation on unknown terrain. Marine engineering, underwater drones with AI inspect oil rigs, pipelines, and ship hulls. Civil infrastructure, AI-powered drones survey construction sites, bridges, and power lines. With these drones, you can control and you can, all the situations are under control. You can control all the gadgets simultaneously, and day by day, these drones give you important information about the situations. There will be really advantage for you to sustain all the system on track. And when we focus on recent developments, we can say cobots, this collaborative robots, work alongside humans, adjusting grip, force, and movement in real time. Also, reinforcement learning, RL, it enables autonomous systems to optimize control strategies through trial and error. Also, AI in autonomous vehicles, it's really popular in these days. Self-driving cars and trucks are engineering marvels, blending AI with mechanical and electrical engineering. It has benefits like increased safety, because robots in dangerous environments gives humanity increased safety, and also efficiency, and robots can work 24/7 operation. there is no need, there is no continuous need for robots to work, but for humans, when we talk about for humans, you need to have a rest, and because of this, you need to change human shifts for 24/7 operation, or you can find another way. But in robots, it's really easy to work all day, night. And lastly, we talk about AI for problem solving in engineering. Engineering involves complex optimization problems. This is what in engineering's main area. And these optimization problems are minimizing cost, maximizing efficiency, ensuring safety, and also AI is now being used to solve these problems once considered intractable. Let's again talk about examples. First one comes with smart grids. AI balances electricity supply and demand in real time. As you know, for these days, I'm talking about 2025, there is not enough electricity capacity in big volumes, because when you produce electricity from renewable energy sources, you need to sell it immediately, because there is no way to save all these electricities in machines. Electricity comes and goes, and you need to use it. And there is also some balance algorithms for smart grids. You need to find a balance between electricity supply and demand, and especially in real time. And it's really important to use AI to find this balance between these supply and demand. So this is important problem, and you need to find a faster way optimize this balance. So this is a complex problem, and in smart grids, AI usage is getting bigger day by day. And when we talk about civil engineering, AI predicts concrete durability, optimizes traffic flow in urban planning. Also, traffic flow is a complex problem, because you cannot stop traffic. It flows all day and night, and you just need and have to optimize it. Traffic shouldn't be stopped, or as much as you can, you need to make it open roads and no traffic for humans. But this is really a hard situation, and you just need to optimize it, optimize traffic flow in urban. And also this complex problem can be solved with AI support. And the mechanical engineering, predictive maintenance turbines, compressors, or machinery. Predictive maintenance is also important in aerospace, airplanes, or some warplanes. Also, you can use this AI approach in this mechanical engineering area. Also in chemical engineering, you can be able to optimize reaction conditions, predicting yields and reducing hazards waste. When we focus on recent developments, we can say optimization with AI is important in problem solving. AI comes with evolutionary algorithms, for multi-objective problem solving. Optimization is the main area of AI because optimization means you are supposed to try many ways to optimize it and find the best way to get it. And you need, when you try to find the best way, you pass on many ways. So AI do it accurately and faster. Find the best option. And when you use this AI in these areas, I mean optimization, it gives you a smarter model and reduce downtime because time is important in engineering. The next one is anomaly detection. It identifies unusual vibrations, temperature spikes, because as you know, in cars, electricity cars, temperature spikes is really important and is really dangerous when you use it. And you need to spot these temperature spikes and maybe warn the driver to stop or do something different. Identifying this is really important, or as I mentioned, identifying unusual vibrations, because if there is a vibration in the machine, it's also an important warning for you. There should be minimum vibration. Vibration means there is something wrong. And also stress before equipment failure. When you spot all these problems, all these anomalies, it's really important to solve the problem. And when we talk about cloud-based engineering AI, is democratizing access to powerful AI solvers. Cloud-based means we gather all information in cloud and we use all this information to find better options for these problems. What's the benefits? There is higher safety, there is reduced downtime, there is smarter infrastructure. When we talk about challenges, there's also challenges in all these topics, because when you build an AI system, it's not cheap, but after you build it, when you try to use it, all these procedures becomes easier and cheaper. And so it's really important for the first step in AI, but when you implement it, all the other procedures becomes easy for you. And when we talk about example case study, we can say, think about a wind energy company. It deploys AI-powered digital twins of wind turbines. As you know, wind turbines are really expensive, and it should have a long life if you plan to earn good money, and you need to make digital twins of these wind turbines. By the way, the AI predicted blade fatigue months in advance, preventing catastrophic failures. And the maintenance costs dropped by 20%, and the time dropped by 50%, 15%. Also, costs and time drops is really important. And in another case, an automotive company used AI-based generative design for chassis components. It's same in Turkish, chassis components. The resulting is 30% weight reduction while maintaining crash safety standards. All different these areas in engineering. I mean, aerospace and automotive sector or energy sector. There are always positive effects of AI in these sectors. Uh, if you plan to become engineer or medical doctor or professional in healthcare or in engineering, this is really improves your earn and drops your uh, time usage and also save lives because it's really important in security to use AI. As I mentioned just before, you in maintenance or in dangerous situations, you can use AI-based robots, or you can use AI's new pathways to give you how to handle the situation. And it's really radical change in these industries to use AI. In healthcare, all the areas, radiology, oncology, or other areas, can get more accurate decisions. Your decisions becomes faster. You can have personalized outputs, personalized treatment, or same in engineering. You can have personalized problem solving methods. Also for security measurements in engineering, you can use these AIs and calculations before take weeks or months. Now it takes just days, maybe hours, because AI models can now run millions of simulations in some hours, 3 or 4 hours, and generate completely new design solutions, security solutions, or other solutions to the problems. In today, we talked about these main areas. As I told you before, these areas really important faculties in our university. You might be wondering why did we pick these tools? Because as I told you before, one reason these two biggest faculties, faculty of medicine and faculty of engineering, is the two biggest faculties in our university. So I picked these two areas, and it makes perfect sense for us to focus on how AI is transforming these fields. At the same time, these are also the two areas that affect all of our lives directly. For the next weeks, we will keep talking on AI usage in other areas like dentistry, like maybe in some fields of some other faculties in our university. And after 2 or 3 weeks, when we understand the importance of AI, we start to talk about main components of AI and some technical terms about AI. But as I told you just before, for first weeks, we will just talk about how you can use AI in your profession. Thank you for everyone for this week. If you have any questions, you can also email me or send message via YouTube or email. Next week, I will be glad to see you on the same hour and same day. Thank you for coming and listening. This week's topic. Have a good week, everyone. See you soon. Thank you.